This video covers Step 5, Compute Street Parting Variables. We have learned that street parting variables include nodes 1 Q or H, nodes 3 Q or H, node 4 Q or H. There are no parcel level variables. Node means intersection. I'm going to use the term of node or intersection interactively below. To compute these variables, we need to have shift layers of node 1, node 3, and node 4 separately, and also the parcel file contain the parcels within 1 mile buffer of the project area created in step 4. The buffer tool, which is also in Python, will go through each parcel and find the nodes in each layer and return the number of nodes within quarter mile or half mile buffer. The output also text files, each for a node type. We are going to use these text files to update the corresponding variables in the merged table in the final step. So first, we need to create node 1, node 3, and node 4 files by adding the intersections in the project area to MTP SCS regional files. Now let's add the regional files to the map. They are under Parcel, regional files, street parting. We are going to use node 1 2035 shape, node 3, and node 4. So we can see that there's nothing was included in the regional file. We need to make a copy of each of these layers to our working space. And then we are going to add the intersection in the project area to those copies. To make a copy of the file, we to go to Data, Export, and then this is node 1. We can name node 1. Yes, we add it to the layer. And then node 3. Do the same to node 4. Now let's remove the regional files. So we can see this node 1, node 3, and node 4 is a copy of the regional files. Next step is to get intersections in the project area. There are two ways. One is from a sketched street network. The other one is to use synthetic node with node density lookup table by place types described in SacSim document page 1-7 to 1-10. We used this method in regional scenario. This method estimated node 1, node 3, and node 4 per acre based on the place type of a future development area. These estimations were applied to a grid of synthetic nodes of fixed areas. Now I'd like to go through the process of using synthetic node method. First, select parcels. Select parcel polygons with development on them in the project area and save the selections as project parcel poly 2. To do this, go to selection. Now we want to turn the parcel points with development on them, and then we go to selection, select by location. And so our target layer will be project parcel poly, and the source layer will project parcel points. And then we say OK. We see this parcel polygon selected. Then save this selected parcels. We can see project parcel poly 2. We add this to the map. Then open the attribute of this new map. We want to add a field called place type. We want to associate the place type from the point table to this polygon layer. To do this, we want to join by parcel ID in project parcel pt2. Also use the parcel ID. We say OK. And then we want to calculate the place type equal the place type in the project parcel pt2 layer. So now we get type, and then we want to remove the join. Now add the synthetic node layer to the map. This layer is under street pattern 2. We call das_2 acre shape. And then we want to select the dot within our developed parcels. We want to select by location, and then the target layer will be .2 acre. So our source layer is our project parcel poly 2. And then we say OK. You see those dots selected. And then we want to save this selected dot to a new file. We can call dots to acre project. Now let's remove this layer. Now open the attribute table of this .2 acre project layer. The next step is to associate place type and grid ID to each of these dots. To do this, we need to spatial join the polygon layer we just created to this with this dot. First, we want to turn off all the fields except grid ID and the place type in this polygon layer, and then we say OK. And then we want to go to Arc toolbox, or analysis tools, and overlay. We use spatial join. So our target feature is that 2-acre in this project. The join feature will be the project parcel poly 2. Our output, we want to use this 2-acre per, we can use 2 there. See, now we see the grid ID and the place type will be in the output table. And then we say OK. So this file will be the output from the spatial join process. Let's open the attribute table of this file so we can see grid ID place types in this table. Grid ID will be used in the buffering process. And we are going to associate the node densities, the node density to each of these data based on place type. Now let's add the node lookup table. It's also on the street pattern folder to the map. So let's open the table, take a look. So we'll see for each of the place type, we have the density, the values per acre for each of type of the node. But here we call link 1, link 3, or link 4. Basically, that for the node 1, node 3, and node 4, and the place type. We want to join this table to this layer. We want to say join by place type. And then we see place type here. We see no. And then before we remove the join, we want to add 3 field. We can call it node 1. We use double. Node 3, double type. Node 4, double type. So now let's calculate this 3 field. We go to field calculator. We want them, so the node 1 will be equal the link 1 in the node lookup table. And node 3 will be node lookup link 3. And node 4, link 4. So now let's remove the join so we can see the node density was associated to each of these dots. Now let's merge this file to each of the layer. It's the original copy. So to merge this file to original copy, we go to Arc Catalog, and then we go to our working folder, and then we have this copy of original file node 1, node 3, node 4, and then want to click each of the layer, and when we use load function, load data, we see next. So the input file will be this Start to Acre Project 2. It's open, add, next here. We leave everything's no, and then for the unit, we want to use the corresponding units. The units basically is the density, the node density here. So we want to, for this layer, because it's node 1, we want to use, see the grid ID, we couldn't find the corresponding grid ID because the node, the variable type is different. So here we cannot continue, we have to cancel here. So we go to this layer, then add a new field. We make a grid as long integer, and we want to calculate this field as grid ID. Now we go back to catalog, we go to load, see next here, the input data will be this file, and then we see add, next here, and then we leave no one here. So for the units, we want to have node 1 for this layer, and then the grid here. We say next here, see finish. Then we go to node 3, we do the same. Next, the input also this file, and say add, next, no one here, only unit will be node 3 here because this is node 3 layer, and then the grid ID is grid, is in next, finish. And then do the same to node 4, next, the same file, add, next here, no one. So the unit here will be node 4, and then grid ID is grid, you see next here. So now we are done merging the intersections created from synthetic node to this regional layer. Now let's take a look of newly merged file. We want to remove this first, and then we add back again. Let's turn off these layers. Let's add back this node 3, node 4. And then you see the synthetic node was added to this regional file. Now let's take a look at the attribute table. So we can sort. Now select some of the points in this layer. So we can see this is node 1. See the density for this node is 0.065. If you go to node 3, so the density will be 0.26. We want to clear selections. Before we go into the buffering process, we need to do one thing. We need to calculate this string ID as n plus this object ID because for the record of newly added, they are empty there. We do the same for then we do the same for node 4. Now we are ready to run the Python script to compute those variables. Let's go to the to directory. The to directory is under Parcel, regional files, tools, and the node buffer. So the script and the files needed for this tool is all in this directory. Before run the script, we need to modify the node's main program.py file. So first, we need to specify the parcel file we need to use. So the parcel file will be project parcel painted 1 mile file. And then we want to run the node 1 first. We need to run 3 types for each of the layer. So each of the type, the node 1. And then the scenario name here can be any text, but because this is part of the name, so we want to use node 1 here. And then the buffer field is the units. So now we want to save. It's already saved. Then we go to a command window, which is already there. So then we type python python nodes main program.py. We say OK. So it started. So each of the layer will take about 1 minute, I think, because this is a small file. Okay, so the run for node 1 is done. Let's take a look at the output table. So output table will be in this directory. The output is the text file. Will be like node1.txt. Let's open the file, take a look. So there are 4 fields in this file. So the p string, which is a unique identifier to the parcel table. And then there's units S, units Q, which is the quarter mile buffer value. Units H is a half mile buffer value, and units M is a 1 mile buffer value, which is we are not going to use in this process. Now we need to do the same for node 3. So we need to run the node layer. The parcel layer will be the same. So the node layer will be node 3. And then the scenario name, we say node 3. And then we save the file. And then we rerun the buffer process. So the output in this process will be nodes underscore 3.txt is the same format as the node 1. We are going to take this output to the last step to update the corresponding variables in the merged regional file. So basically we are done with step 5. To save time, I want to end the video here.